This video is to show the mechanism for the Claisen condensation of propyl propanoate. The propanoate is the carboxylic acid end, and the propyl is the alcohol piece. Both of these have 3 carbons. The base in this case is, instead of ethoxide, which we usually use, this is propoxide, which is the alkoxide that comes from deprotonating propanol. We do that because we need the base to match the alcohol. Otherwise, your ester is going to transesterify and turn into some ethyl and some propyl. So the first step in the mechanism is the propoxide deprotonates at the alpha carbon to give us the enolate anion. One thing that's important to recognize is that propoxide is not a strong enough base to deprotonate the ester completely, so we'll also have some neutral molecules floating around in solution. This is key if we want to have the Claisen condensation happening here. So the next step happens when the enolate attacks another neutral molecule of the ester to give us a tetrahedral intermediate. The tetrahedral intermediate has a negative charge on the oxygen of the ester that was just attacked by the other ester. The next step happens when the carbonyl bond reforms and alkoxide leaves to give us what looks like the Claisen product, and you think we should all be done now and not have anything else happen. But the reality is the base in this solution is strong enough. Actually, it's the same base that it has been. It's just that this product is more acidic than the starting material was because it's next to 2 carbonyls instead of just 1. So because the base is still in solution, it's going to deprotonate it there and give us this anion. And if we only used a catalytic amount of base, the reaction would happen only a catalytic amount. It would not go to completion because at the end, the propoxide base is used up again to deprotonate at the alpha carbon. And so if you use less than a full equivalent of base, you'll get whatever amount equivalent of base, that's how much reaction you'll get. So you need a full equivalent of base. And in order to get the neutral product, you also need to have an acid workup. Now the next thing I'm going to do here is show you a bunch of numbers on all the things so you can keep track of what happened. So carbons 1, 2, and 3 on the enolate attack carbons 4, 5, and 6 on the neutral ester, and you can follow where 1, 2, 3, 4, 5, 6 are in each of the intermediates until we get to the end of this mechanism.